Hi, I am your host and guide for this course on data science with Python. Along with Simplilearn, I will take you through this lesson that will teach you how to use NumPy for mathematical computing. In this lesson, you will get to know what NumPy is and why it's important. You will also learn the basics of NumPy and its fundamental objects. You will see how you can create and print a NumPy array and apply basic operations over it. You will explore different ways to wrangle data using shape manipulation and copying methods. You will also look at how you can use NumPy to execute linear algebraic functions and build basic programs. You have already seen what lists are and what you can do with them. To quickly recap, a list is a basic Python data structure which can hold multiple values of multiple data types such as integers, floats, strings, and so on. It also allows you to add, update, or delete individual values in it. In this example, we have two lists, distance and time. Each list holds 4 different readings. These readings correspond to each other. For instance, the first element in the distance list is 10 miles. This value corresponds to the first element of the time list, which is 0.3 hours. Using these lists, if you try to calculate the speed, which is equal distance over time, it will give you an error. That's because mathematical functions can't be applied over an entire list. Now, let's see how NumPy solves this problem. NumPy is a Python library that supports a data container called arrays. Arrays are like lists, but they can do something that lists can't. They easily allow you to apply mathematical operations over the entire dataset. Let's see how this works. First, you need to import the NumPy library. Then you need to convert the distance and time lists into NumPy arrays. Apply the formula for speed using these arrays. You can see that NumPy easily generates an output for each of the 4 readings. This property of NumPy makes a data scientist's job much easier because it helps them to easily manipulate data by applying mathematical functions over a given dataset. NumPy stands for Numerical Python and is the foundational package for mathematical computing in Python. It has a huge set of built-in functions. There are several properties of NumPy. It supports fast and efficient multidimensional arrays, or ND arrays as they are called. It executes computations and mathematical calculations in an element-wise manner. It performs linear algebraic operations, Fourier transformations, and random number generation. It has tools for reading and writing binary or text data from and to disks. It can efficiently store and manipulate data. It has tools to integrate language code, such as C and C++. Let's take a closer look at ND array in the next slide. An array is a collection of values that can be added, removed, and changed just like a list. But unlike a list, it is homogeneous. That is, it can only hold a single type of data. It's also multidimensional. It supports mathematical functions and is fast and efficient. Before we go into more details, let's try to understand how ND array is actually used. For data scientists, it all starts with a problem or a question and a dataset. They then write a program to solve the problem or answer the question. A program can have multiple algorithms that contain business logic, such as functions or element-wise computations or mathematical operations. Algorithms within a program need to share data to manipulate it and execute the embedded logic. An ND array makes this task simple. It's used as a primary container for the data and is available throughout the program for fast and efficient computing. Arrays can be one-dimensional, two-dimensional, three-dimensional, or multi-dimensional. The best way to visualize an array is as rows and columns. You can also look at it by its dimensional axis or rank. You can think of a one-dimensional array as a single row of values. So a one-dimensional array has one axis or rank 1. Two-dimensional arrays can be visualized with rows and columns. This means that it has 2 axes, or rank 2. A 3-dimensional array has 3 axes and can be visualized as a cube, which has height, width, and length. Similarly, multi-dimensional arrays have multiple axes. Let's look at how to create and print a NumPy array. Before you start, import the NumPy library. Give it an alias name, NP. This is a standard practice which will be followed in all the examples and projects in this course. Then, create a new ND array. Name it in such a way that it is self-explanatory. This is a good practice, as it will help you identify variables easily. To create an array, use the syntax np.array as shown here. To print this array, simply type the print command followed by the variable name. You can also create an array of zeros using the zeros method. Please note that the syntax here is slightly different from the one used to create regular arrays. Similarly, you can create an array containing only ones. Using NumPy, you can also create an empty array. What happens in this case is that NumPy fills in the array with random numbers. Though there are some uses for this function, it should be used with caution, as the array would contain the random numbers unless you set them manually. A range is a very common method used to create NumPy arrays of certain data length. For example, here we create a NumPy array of length 12. Note that the array contains 12 elements, starting from 0 and ending with 11. You can reshape this one-dimensional array to a two-dimensional array, or 3 rows and 4 columns using the reshape method. Linspace is a method which takes 3 arguments. The first number indicates what the start element of the array will be. The second number indicates the end of the array. The last number shows what the interval will be. The interval instructs how many evenly spaced elements should exist in the array, including the first and the last elements. As we already saw, the arrange and reshape methods can be used to create